Assalamualaikum warahmatullahi wabarakatuh. Today, I would like to present my final year project proposal titled The Implications of Microplastic Pollution on the Ingestion Rate of Oyster. Before that, my name is Muhammad Abdul Muhammad Benik, S54783, Bachelor of Applied Science Fisheries, and my supervisor is Dr.Wan Muhammad Rauhan bin Wan Hussin. The field of my study is benthic ecosystem function, with project title is The Implications of Microplastic Pollution on the Ingestion Rate of Oyster. Chapter 1, Introduction. Background of study. According to US National Oceanic and Atmospheric Administration and the European Chemical Agency, microplastic defined as a fragment of any type of plastic less than 5 mm in length, and it has become an environmental threat to natural habitats and humans, and also have negative effect on marine species. Oyster is a filter feeder bivalve that live across the benthic region of the aquatic ecosystem. As a result, these animals digest and assimilate high amount of microplastic in their body, which could affect their physiology and also the health of the marine environment and human consumers. Because of what they consume various nitrogenic compounds such as phosphate, plankton, detritus, bacteria, and also dissolved organic metals. In this study, the oyster will be used as bioindicator for the effect of microplastic, determined by the ingestion rate of oyster on the microplastics. Okay, problem statement in this research. First, increase in human population, development and plastic-based consumption cannot be avoided. Then, true uptake of microplastic by oyster based on ingestion and ejection dynamics need to be explored. The last one is the relationship between diverse types, shape, and size of microplastic and how it affects the oyster need to be explored further. Significance of study. This discovery will serve as a foundation for future research into the effect of microplastic on oyster and how it can cause their growth, quality, and death. From this study, it will discover the ingestion rate of oyster toward different sizes of microplastic. In addition, the use of different size microplastic in the experiment will show how much the particles accumulate in the oyster and how the multiple sources of plastic waste impacting the aquatic benthic microorganism. The objective of this study is, first, to determine the presence of microplastic in the tissue of Magellana species. Second, to determine the effect of microplastic on the oyster based on the survival, growth rate, performance of Magellana species. Chapter 2, Literature Review. Oyster is a mollusca under phylum Bivalvia with two shells made out of calcium carbonate. It is a filter feeder organism with filtering through the gill. It also cycling the nutrient with consuming the nitrogenic compound surrounding. Oyster live in estuaries, sounds, subtidal, bays, tidal creek from brackish water to seawater. Why I choose oyster? It is because it play an important role in aquatic ecosystem. First, it provides valuable shelter and habitat for many other estuarine organisms, also improving water quality and reducing bank erosion. Second, it farmed in worldwide for human consumption. The production of mollusca were increased by the year. Oyster was one of the major species produced in world of aquaculture based on FAO 2020. According to Bringer et al. 2020, the presence of microplastic also has been reported in almost all studied habitats around the globe. Oceanographic model studies confirm that the presence of microplastic up to 2.141 million tons of microplastic across the Atlantic, Pacific, and Indian subtropical gyres. And this is the taxonomy of Magellana sp. And this is the classification of Magellana sp. Next is materials and method. And this is the overview of my methods. First, sample collection. 52 oyster, which is Magellana species, will be captured and it collect from Merchant Lagoon, Marang, Terengganu. First, before we culture, I will measure the sample with length, height, and weight. Second is experimental design. Sample we purified for 2 days before culture in the tanks. 4 tanks will fill with 10 liters of seawater and aerations. Each tank I will fill with 13 oyster. One tank is controlled and 3 tanks more is manipulated with 100 to 230 and 300 microns meter size of microplastic with the density 50 gram of microplastic per liter. It will capture for 40 days long. The third is algae preparation. The algae that I use is Nanochloropsis sp, which is I will feed the oyster every 2 days. The fourth is microplastic preparation. The microplastic that I use is high density polyethylene HDPE, like plastic bottle that is fluorescent. Why I use fluorescent is because it will be clearly more seen under microscope. Then the plastic I will cut into small pieces. Then it will be blended in dry mill blender. To get the size that I want, I will use micro mesh sieve, which is 100, 200 and 300 micrometer in size. The fifth is microplastic exposure. The oyster will be exposed to microplastic for 40 days, which 1 control non-microplastic and 3 manipulated with 3 different size but same density of microplastic. The sixth is depuration process. 1 sample collect from the each tank every 7 days. It will transfer into new beaker filled with 1 liter of filtered seawater and it will be left for 3 days. 7. Abundance of microplastic. After depuration, all oyster removes. 5 mm of water will be taken out from the water sample in beaker. Then, the rate of suspended microplastic will be counted under hemocytometer. And this is the formula how to calculate them. 8. Growth and motility measure. Measure will be done every 7 days for 40 days. Sample from each tank will be collected. It will measure length and height of shell using electronic calipers, and also I will measure motility of oyster. For the weight, I will measure with shell. First, oyster will be air dried for 5 minutes under room temperature and it will be weighed to nearest 0.001 gram on the electronic scales. The last one is statistical analysis. First that I will analysis is ingestion rate of oyster, which is between microplastic and non-microplastic. The data that measure is mean of motility and growth and also abundance of microplastic. The data that I will present is by graph by using Microsoft Excel and variance analysis by ANOVA, and also mean and standard deviation. I will be using the software IBM SPAS 26.0. Chapter 4, Expected Results. And this is the expected result based on the journal that I have read. First, survival rate. The death of oyster increased due to the increase of exposure period to microplastic. Second is growth rate. To measure growth rate, it will need 1 month, maybe the minimum period for measurement changes in size. The weight of oyster increased initially, then decreased over time. And the last one is abundance of microplastic. The particles suspended more in tissue by increasing of microplastic size. Microplastics of different size have the potential to be accumulated in the bivalves. This is the reference that I have used. The last one is Gantt chart. This is the Gantt chart that I have planned, which is from March 2021 to February 2022. Okay, that's all from me. Thank you.